Look at a clock right now. Just, picture the second hand ticking.
Right. Which we all just kind of take for granted.
Exactly. You probably assume that every single second ticking by is mathematically identical to a second that passed 1,000 years ago or a million years ago.
Yeah, we view time as a constant straight line.
A straight line. But what if time isn't a line at all? What if time is actually like a mechanical gear?
Oh, I love where this is going.
And what if, right now, our entire solar system is being crushed into the fastest, tightest, most pressurized spin in cosmic history, literally making you feel like the days are just flying by?
I mean, it sounds completely like science fiction, but this is exactly the intersection we're exploring today.
Which I am so excited for.
Me too. So we're diving into a set of sources that propose a really specific mathematical framework. It's known as the 1.2.4.8 cosmic model.
Okay, 1.2.4.8.
Right. And this model argues that the universe doesn't just, sit statically in the void. Instead, it acts like this giant, well, the sources call it a mechanical egg.
A mechanical egg? That's a wild visual.
Yeah, it's a system that systematically expands and contracts over these massive, vast epochs of time. And as it does, it brings the planets closer to the sun, which fundamentally changes the speed of time itself.
And so the mission for this deep dive is to figure out the actual mechanics behind that claim. We are going straight to the source material, which is absolutely fascinating because it forces us to compare two entirely different
You
worlds.
see very different methodologies.
Well, we're taking the ancient Vedic texts, specifically this foundational astronomical treatise called the Surya Siddhanta, and we are laying those thousands of years old calculations directly on top of modern NASA astrophysics.
Which is such a bold comparison.
Mhm.
Because, the Surya Siddhanta isn't just a collection of myths.
Not at all.
It's one of the oldest known texts on archaeoastronomy. It calculates planetary diameters, eclipses, orbits, real hard data.
Real numbers. And what we want to find out today is whether the specific numbers recorded in that ancient text actually align with what modern satellite data is telling us about our physical reality right now.
Because if they do, we are talking about gravitational shifts that basically dictate the flow of human history.
Exactly. But before we throw a bunch of orbital mathematics at you, we really need a mental map.
Yeah, we need to ground this.
Right, we need to visualize what these cosmic ages, these yugas as the texts call them, actually look like structurally. If the universe is expanding and contracting, how do we picture that?
Well, the sources provide this really brilliant visual right out of antiquity, which is the Yagya Kund.
Okay, the Yagya Kund. For those who aren't familiar, let's unpack that.
Sure. So the Yagya Kund is the ancient Vedic fire altar. If you've never seen one, just imagine a stepped geometric fire pit.
Like a terraced pyramid, but inverted, or, well, going upwards.
Yeah, going upwards. Usually built from very specifically measured bricks, used for rituals. But it's not just a fireplace. The architecture of this altar is designed as a literal scale model of cosmic time.
So picture the very base of this altar. It's called the Vedi. It is the widest, broadest, most foundational part of the entire structure.
Right.
And in this cosmic model, this wide base represents the Satya Yuga. This is the universe in its most expanded, totally relaxed state.
The golden age, basically. You have maximum distance between the planets,
Uh-huh.
and therefore minimal gravitational pressure.
Right. But time doesn't stay there.
No, it doesn't. As you move up the altar, you encounter this series of steps called mekalas.
Okay?
So the first step up from the base represents the Treta Yuga. You've moved up, and the geometric space is narrowed. The physical walls of the universe, so to speak, are beginning to contract.
Okay, so it's tightening. Then you step up again to the middle step. This is the Dwapara Yuga. The altar is getting significantly narrower now.
Very much so.
And finally, you reach the top step, the smallest, most constricted part of the altar where the fire is actually burning. And this represents the kaliyuga.
Exactly.
This is where the expansion ends entirely and the physical pressure and contraction are at their absolute highest peak.
It's such a great architectural metaphor. But, the sources offer a second analogy that I think translates this directly into orbital mechanics for us today.
Oh, the mountain bike one. I love this one.
Yeah. Think about a multi-speed mountain bike, specifically the gears on the rear wheel, the cassette.
Okay, so in this analogy, the sun is the center of the wheel, the axle.
Right.
Now think about when you're riding and you shift the chain onto the absolute largest gear on that rear wheel, the one furthest away from the center.
Your pedaling slows down.
Exactly. The chain has a long way to travel. There's less tension, less pressure, and just a much slower rotational speed, that large outer gear. That represents the Satya Yuga. The universe is expanded, the celestial bodies are just sort of riding on that outside relaxed track.
But then, you shift gears. You drop the chain down, step by step, until you're on the absolute smallest gear on that rear cassette.
The one right tight against the center axle.
Yes. And if you've ever done this while riding, you know exactly what happens. Suddenly your legs are just spinning frantically to keep moving.
You're just spinning out of control.
Exactly. The rotation is incredibly fast. The tension, the mechanical pressure in the system is intense. That smallest, fastest gear, hugging tightly to the sun, that is the kaliyuga.
I love that visual because you can genuinely physically feel the tension of that tiny gear. But I have to stop you here.
Uh-oh.
Yeah, because representing the listener, I'm feeling a healthy dose of skepticism right now.
Fair enough.
An altar and a mountain bike gear are fantastic metaphors. But comparing an ancient text to modern NASA data feels like a recipe for cherry picking.
I hear that a lot.
Right, like are we just scouring the Surya Siddhanta to find random numbers that conveniently match today's satellite tracking? Are we seriously suggesting that physical massive planets in our solar system are literally moving millions of miles closer to the sun?
It's the natural question to ask. But the data presented in the sources argues strongly against cherry picking. Because the shift isn't just random.
Okay.
It follows a highly specific systemic mathematical rule that applies across the board. The model proposes that 1.2.4.8 acceleration ratio we mentioned earlier.
A multiplier.
Yes, every time the universe shifts a gear, the distances and speeds change by this exact multiplier. And to prove this isn't just, ancient mysticism, the sources map this directly onto Johannes Kepler's laws of planetary motion.
Okay, let's unpack this. How does an ancient text's shifting gears map to 17th century physics?
It all comes down to Kepler's third law. Without throwing too much algebra at you, Kepler proved a fundamental rule of gravity. The relationship between a planet's distance from the sun and the time it takes to complete an orbit is totally fixed.
Right. And the simplest way to think about that is like swinging a ball on a string around your head.
That's the perfect way to picture it.
So if you let the string out long, the ball makes this wide, slow circle. But if you pull the string in close to your hand, the ball has to whip around incredibly fast to keep from falling inward.
Precisely. The shorter the gravitational leash, the faster the planet has to run. And what the sources show is this stunning correlation between the extremely long leashes recorded in the ancient Surya Siddhanta and the shortened leashes recorded by NASA today.
And we measure this in astronomical units, or AU, right?
Yep, 1 AU is just the distance from the Earth to the sun. It just makes the math a lot easier to visualize.
Okay, so let's look at the macro structure first. The giant outer planets. Let's take Jupiter.
Great place to start.
So in the ancient texts, Jupiter is the factor of heaven, or the divine. According to the Surya Siddhanta's calculations, during the expanded Satya Yuga, that large, slow, outer bicycle gear Jupiter was sitting way out at just over 17 AU, meaning it was 17 times further from the sun than we are.
But as the cosmic gears shifted into the Dwapara Yuga, the universe contracted. And the text records Jupiter moving dramatically inward, dropping from 17 times our distance down to just 6 times our distance.
Which is a huge jump. And here is where the NASA data comes in. Where is Jupiter today?
It's at roughly 5.2 AU.
Wow! So it pulled in from 17 down to 6 and is now sitting near 5.
The exact same systemic collapse is seen with Saturn too, which, in the texts, represents time and karma.
Okay.
In the wide-open Satya Yuga, the ancient text puts Saturn at a massive 31.5 AU away. By the time the gears shifted down to the Dwapara Yuga, it had contracted to 11 AU.
And today?
Today, NASA measures Saturn at about 9.5 AU.
That's wild.
It really is. It's a consistent, systemic inward collapse. Mars shows the exact same trend, dragging in from nearly 5 times our distance down to just 1.5 times today.
So the outer boundary of the solar system is essentially collapsing inward. That's the macro view. But the sources point to Venus as the internal sort of psychological driver for us down here on Earth. And the claim they make here is just wild.
It is wild. So Venus is traditionally the planetary factor of illusion and materialism. If we track its distance through the shifting yugas, we see it start in the Satya Yuga at roughly 2.3 times our distance from the sun, so it's far away.
Far away, yeah.
But by the Dwapara Yuga, Venus had crossed inside the Earth's orbit, closing into about 0.8 AU. And today, NASA puts Venus at a very tight 0.72 AU.
It is incredibly close to the sun. And to us.
Very close.
And the argument the source is present is that this physical proximity isn't just, like, cosmic trivia. They claim that Venus being pulled so intensely close to the sun in the Kaliyuga is the actual physical mechanism driving the intense rise of materialism, illusion, and technology that completely dominates our modern world.
Yes, that's exactly what they're saying.
But how? I mean, what is the physical mechanism there? How does a planet's proximity to the sun make a human being on Earth obsess over a smartphone or their bank account?
Well, the sources suggest we need to think about planetary bodies not just as giant rocks in space, but as massive electromagnetic and gravitational oscillators.
Oscillators. Like they're broadcasting.
Exactly. Every planet emits a frequency, a resonance. When the solar system is expanded on that large gear, those frequencies are kind of diffuse. But when you pull everything onto that tiny high-pressure gear, the energetic density increases massively.
So it gets louder, essentially.
Right, and the texts argue that human consciousness and our nervous systems are deeply tethered to these orbital frequencies. So because Venus, which is the resonant frequency of materialism and external illusion, is now dominating the inner solar system, our collective consciousness is essentially forced to tune into that station.
Wow, so the physical tightening of the solar system creates a corresponding materialization in human thought.
Exactly. The mechanical pressure of the small gear changes the psychological pressure on humanity.
I am fascinated by how the ancient numerical distances match the modern narrative, but it brings up a huge critical question of physics.
Let's hear it.
Think about the sheer mass of Jupiter and Saturn. If all these gas giants are physically migrating inward to smaller gears, dragging their massive gravitational fields closer to the center of the solar system, how does that not violently impact Earth's actual movement?
That's the million-dollar question.
We are sitting right in the middle of this shifting cosmic gearbox. We have to feel this physically.
We do feel it physically, and it leads perfectly into the final and perhaps most important piece of the puzzle. The shifting of these massive planetary gears doesn't just change the scenery in the night sky. The changing gravitational pull directly alters the Earth's axis.
Okay.
And by altering the axis, it alters our literal perception of time passing.
Okay, walk us through the mechanics of that, because changing how time flows sounds impossible.
So we need to look at the Earth's wobble, which astronomers call axial precession.
Right.
The Earth isn't spinning perfectly straight up and down, it's tilted. So as it spins, the very top of the axis slowly traces this massive circle in the sky, exactly like a spinning top does as it starts to slow down.
Right. This is why our North Star changes. Like a few thousand years ago, the North Star wasn't Polaris. It was a different star because our axis was pointing at a different part of that giant circle.
Exactly. Now, traditional modern astronomy observes this wobble and assumes it happens at a completely constant speed.
Okay.
Today, it takes roughly 72 years for the Earth's axis to trace just one single degree of that 360-degree circle. It is a very, very slow wobble.
But our sources disagree with that constant speed.
Strongly. They introduce a concept from the texts called the Yugantar Master Thesis.
Yugantar Master Thesis.
Right. And this thesis argues that because the giant planets like Jupiter and Saturn are shifting inward on those gears, the gravitational torque they apply to the Earth's equatorial bulge is constantly changing.
Okay, think of torque as a twisting force.
Yes. If the massive planets are closer, they pull harder on the Earth. If you apply more twisting force to a spinning top, what happens? The speed of its wobble changes.
It accelerates.
Yes. The master thesis argues that the wobble accelerates in that exact same 1.2.4.8 ratio. It is not constant at all.
So let's map out that timeline, because the numbers in the sources really drive this home.
Yeah, let's look at the math.
Back at the end of the Treta Yuga, when the universe was still somewhat expanded and the torque was low, the Earth's wobble was lazy. It took about 90 years for the Earth to wobble just 1 degree. So time, as measured by the stars, moved slowly.
But then the gears shifted. The massive planets moved closer. The gravitational torque squeezing the Earth increased. By the average Dwapara Yuga, the wobble had sped up significantly. It now only took about 76.8 years to shift 1 degree.
The top was spinning faster, wobbling tighter.
Exactly.
And then we hit the final stage of the Dwapara Yuga. The sources describe this as a time of extreme suffocating crisis. The solar system is compressing hard, the planets are pulling into their tightest orbits, and because of that immense gravitational torque, the Earth's wobble shrinks to a terrifyingly fast 45 years per degree.
I mean, think about the physical reality of that. The cosmic clock is literally ticking twice as fast as it was in the Treta Yuga.
It's insane.
The mechanical pressure on the Earth and on human consciousness is immense. Everything feels frantic because planetary physics is literally frantic.
But wait, if the wobble dropped to an insanely fast 45 years per degree during that crisis period, why does modern science measure it at 72 years per degree right now?
That's the catch.
Did the gears shift backward? Did we somehow slow down?
This is where understanding the vast scale of these cycles is totally crucial. The sources explain that we are not currently stuck at the absolute bottom, highest pressure point of the kaliyuga. We are actually in a transition period.
Oh, interesting.
Yeah, it's a juncture between the kaliyuga and the next descending Dwapara Yuga.
It's like we're finally shifting the bike chain back up to a slightly larger, more forgiving gear.
Exactly. We're recalibrating upwards. The extreme 45-year compression has passed. As the planetary system begins to breathe and shift slightly outward again, the gravitational torque lessens, and the Earth's wobble is slowing back down.
So it's slowing down to 72.
Right. It is currently settling at a snapshot of roughly 72 years per degree. Modern astronomers look at their instruments, they see the number 72, and they assume it's a permanent constant.
Right, because that's all they can measure right now.
Exactly. The ancient texts say, no, you're just looking at a single frame of a very long movie. You missed the part where it was 90 and the part where it was 45. 72 is just what the speedometer reads right this second while we are decelerating.
That reframes astronomy entirely. But why is this recalibration happening right now? Who or what is shifting the gears?
The sources provide a cosmic context that scales way beyond our solar system. The texts state that we are currently in the exact middle of what Vedic astronomy calls a manvantara and also the middle of a kalpa.
Let's define those for a second because the scale is really hard to grasp. A kalpa is essentially an eon in Hindu cosmology, right? It's often described as a single day in the life of Brahma lasting billions of years.
Billions.
And a manvantara is a fraction of that, but it still spans hundreds of millions of years. These are the absolute macro cycles of the universe.
And what happens in the exact middle of a macro cycle like a kalpa? A massive polarity shift.
A pole shift.
But not just the magnetic north and south poles flipping here on Earth. The text suggests we are currently triggering the beginnings of a galactic and cosmic pole reversal. The entire orientation of our local galaxy is shifting.
Wow.
That massive system-wide inversion is the underlying engine driving these gravitational shifts in our solar system. It is the literal hand on the gear shifter, pulling the chain from one sprocket to the next.
A galactic pole reversal. We started this deep dive looking at the brick steps of a Vedic fire altar, and we've ended up at the reversing polarity of the Milky Way.
It's a journey.
Let's synthesize this journey. We set out to understand this 1.2.4.8 cosmic model and how the universe acts as a mechanical egg that expands and contracts.
Right, and we started with the foundational structure. The Yogikun showed us the geometric shape of time broad and relaxed at the base in the Satyuga, narrowing to a point of intense pressure in the Kali Yuga.
And the mountain bike cassette analogy made it so visceral, we could practically feel the mechanical difference between the slow, easy rotation of the outer gear and the frantic, high-pressure spinning of the inner gear.
Then we looked at the literal distances. We used Kepler's law of planetary motion, the idea that a shorter gravitational leash requires a faster orbit, to map the ancient data from the Surya Siddhanta against modern NASA measurements.
Right.
We watched massive bodies like Jupiter and Saturn, along with Mars and Venus, literally pull closer to the sun, proving that the solar system is, in fact, systematically contracting.
And we explored the philosophical fallout of that, how Venus sitting tightly on the inner gear might be radiating the very frequencies that drive our modern materialist, technology-obsessed age.
Finally, we discovered how that gravitational shift, the changing torque applied by those inward-moving planets, literally speeds up the Earth's axial wobble. We saw the perception of time compress from 90 years per degree down to a terrifying 45 before recalibrating to the 72 we experience today as our galactic poles begin to reverse.
It fundamentally changes how you look at a ticking clock or the night sky. So the next time you feel stressed or rushed or like there just aren't enough hours in the day.
Don't just blame your schedule or your lack of time management. Remember the actual mechanics of the universe you inhabit. You shouldn't feel bad about feeling pressured. You are quite literally riding on the universe's smallest, fastest, most pressurized bicycle gear.
Right.
The gravitational torque of the entire collapsing solar system is squeezing the wobble of the Earth beneath your feet.
That is a wildly comforting way to look at being busy. Like, sorry I'm late, the galactic pole is reversing.
Works for me.
But before we wrap up this deep dive, I want to leave you with one final lingering mystery pulled from the very edges of our source material. We've spent all this time talking about how shifting gears compress time and speed things up, but what if they can also do the exact opposite?
Okay.
What if a specific planetary alignment can create a cosmic lag?
It is a really provocative thought. If torque can accelerate the wobble, it stands to reason it could theoretically arrest it.
Exactly. So consider the ancient Indian epic of the Draupadi Swayamvar. It's this famous story of a legendary archer named Arjun who has to hit an impossible moving target just by looking at its reflection in water, all in order to win a bride.
Right, classic myth.
But our sources suggest this wasn't just a fairy tale of good aim. They argue that Arjun relied on a literal 1,920-year cosmic lag, a highly specific gravitational pause in the planetary gears, to hit a target that would otherwise be physically impossible due to the normal rotation of the Earth.
That's incredible.
Which makes you wonder, how much of what we completely dismiss as ancient magical mythology is actually just incredibly complex, misunderstood orbital mechanics waiting to be decoded? If the mechanical gears of the universe can speed time up, can someone who understands the math find the exact moment it stands still? Something to think about the next time you feel like the days are just flying by.